Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. In our recent discussion, I have mentioned about the advantages of mixed method over individual approach of qualitative and quantitative methods. At the end of that particular lecture, I also mentioned that now we'll be discussing something very particular for the research in planning and architecture, that is the spatial method. So in today's lecture, we'll be discussing about the basic fundamentals of spatial analysis and the spatial method that we can use for our planning and architectural research. So today we are at lecture number 53 and the title is Spatial Method in Planning Research. So in this lecture, we will be talking about the spatial analysis in planning research. We will also try to understand the GIS analysis technique, also the application of spatial method in planning, also the spatial decision support system, and finally we will summarize our discussion. Now spatial analysis in planning and research, spatial analysis describe the methods to study the location, distribution of different resources and also the relationship of spatial phenomena. It is important to optimize the traffic movement with minimum use of resources or to enhance the overall quality of life for resident. It is also important that this type of analysis will assist for building sustainable communities. It also helps to predict and assist to tackle the problems in advance. Now these are few key features that we can say that very important when we talk about the spatial analysis. Now before going into the further slide, let us understand what exactly the spatial mean. So whenever we talk about any location, so that location has a geographic position. So this geographic information system or GIS will help to identify that location based on its latitude, longitude, even in some cases when we talk about the elevation, even the altitude. Now in such cases, each and every location is having some unique identity. Now when we have that kind of information with us that this is a location, along with that we also have the locational characteristics in hand. Say this location maybe it's very next to the river bank or it is something very close to some of the core urban area. So based on that we can always have a sense that okay, if it is next to a river belt, so probably during heavy monsoon or maybe if some sort of flooding situation will occur, so this location will be vulnerable. Similarly, if we have a location which is very close to a CBD, central business district, or maybe a core urban area, then also we'll find that okay, all those kind of congestion, all those kind of pollution that are having some sort of high level. Now these are the informations definitely we can record manually, it's good, but nowadays if we try to see that how this is happening or what is the dynamics over time, how a city has grown from a small settlement to a huge settlement. So that can only be very easily understood if you have some sort of spatial data, those kind of location data, and over time. So the temporal data also plays crucial role in understanding that. So whenever you have a satellite image of current date, you can understand, okay, this is the overall settlement, and based on the remote sensing analysis, you can also identify some of the other aspect like what is the land use, land cover, that we have discussed in several other case studies, where it was discussed that how you can get all those kind of NDVI, NDBI, all those indicators or indices to understand the phenomena. Now here the main point is that why all of a sudden we should do all this analysis. It is important because you can say that the urban phenomena, they are not static, it is very much dynamic in nature. Over time, the settlement, they can grow. The population that is increasing, that we witnessed everywhere in the country, or maybe along with this increase, that you must have observed that there is some sort of reduction in the green cover. Also there are issues with the water. Recently we have discussed the case study where we talked about the water stress crisis, etc. So this is another important aspect. Whenever there are certain sort of huge settlement, probably you'll get other consequences like reduction of green spaces, reduction of your water bodies, and different lakes. So altogether, they are all different geographic phenomena. Okay, maybe it is something just like a heavy rainfall in some location, or maybe certain earthquake. There are certain type of changes in overall pattern. So in all such aspect can be very well covered with spatial analysis. So that's why those kind of planning exercises, what will be the future scenario, how the city should be planned, where should be that kind of reserved location, how much green and where it to be distributed. So all such kind of decision can be very well taken if we can take help of this spatial analysis. In this particular image, if you see that it is just nothing but having certain sort of layer. So there are road network, this is one characteristics. Then you have certain settlement, that is another characteristics. You have certain sort of land use and terrain. They are different layers. Maybe many of you or all of you have used certain time the AutoCAD or all this kind of drafting software, where we also create different layers. Similarly in GIS we also have different layers, and then when you merge them, when you overlay them, so that will give you the real scenario. So in one particular set of information, you are interested to understand the elevations of different parts, like how low that particular land compared to the mean sea level, or how the elevation is so high compared to the other locations, so that it will also help you to design the drainage, also sometimes to decide on how you can bring all those transport network, etc. Now coming to the type of data that we used in those kind of platform and spatial analysis. Now coming to the spatial data, the data that we record is definitely will have broad three category. It can be point data, it can be line data, it can be polygon. Now what is point data? So if you just wanted to mark a bus stop or maybe just a monument in a geographic context, so it is nothing but a point source. It may be a railway station, it can be a building, it can be a place to visit. So this is all information that can be captured as a point data. Now next to that is the line. So whenever we talk about the transport network or the river network, so in all such cases it is not a point, it is some line, right? So you have certain kind of transport network, or it may be something, maybe a river, okay, in that case a natural setup that you want to identify. So in those cases they are line data. Now what about the polygon? So polygon is some sort of defined area. Now if you want to go into in-depth analysis of the building footprint, so in a neighborhood you will find that, okay, there are certain plots, okay, or there are certain building. So this plot will definitely have certain area, and that can be a regular polygon, it can be irregular polygon depending on the actual shape of the object. So that is certainly the polygon as a vector data. Now this vector data is used, but along with that also, whenever we have certain sort of printed form of a topo map or something, we also use the raster data, and also sometimes we use the images and then we transform that data to the vector. So raster to vector is very common, and even vector to raster is also as output file you do. Now within that also we need certain attribute data. So here I am just giving you two example of, say, age of the city and the population. So attribute is something that the information that you want to fit it. Now I give you another example. Say the exercise is to mark all the roads in a city. Now in a city you will have different type of roads. Somewhere it is like 4 lane, somewhere it is 2 lane, somewhere it is like having footpath, somewhere it is not having footpath. So there are different varieties, right? Now whenever you draw the line, or when you just try to get that information from the ground with the geopositioning system, those GPS location, when you just transform it to in a map, spatial map, so there you will get the line. And now this line you can also use certain kind of features or certain kind of line weight to differentiate the different type of roads. But more than that, which is the added part in all this kind of spatial analysis, is the attribute table. There you can specify some of the characteristics or the attribute of that particular item. Say if it is just a building, suppose one researcher is interested to mark all the historic building in a city. Now locating them, having the latitude longitude, we can have that point data. Now this is just marking of that location. But now if someone wants to add certain more information to this, like when it was made, okay, which particular architectural style that is followed in that particular building. So all such kind of information we can put it in a table, and then we integrate that information with that point location. Now what is the advantage? Later on, for your analysis purpose, you can always try to make certain kind of clustering, that you are interested that all buildings which are like 300 years old in that location. So you can always make those kind of legend and come up with some meaningful map, okay, some thematic map out of it. So for that, this attribute is very important. Also the metadata you add, and in all this geographic information and all, scale is very important. That final output, whenever you just take it out as a PDF or maybe as a printed document, so geographic scale, that graphic scale is very important. So that you must have observed in some of the drawing. And also the accuracy. So this accuracy of those information will depend on the precision and the resolution, because whenever you transform those information to the vector, so it will depend on what kind of base map that you have. Now if you have some base map where it is giving you a 30-meter resolution, so 1 pixel is equals to 30 meter by 30 meter. So obviously that will be different than if you get a high resolution map of 1 meter to 1 meter. Now depending on what kind of analysis that you are doing, that resolution will also play a crucial role. If you want to perform something at regional level, so probably 30 meter by 30 meter is okay, but if you want to do something at the neighborhood level and all, so definitely higher resolution information maps are required. Now some of them are easily available, free of cost, and some cases like those kind of satellite images, they are also costly. So depending on the research need and all, one has to take a call. Now coming to the sources of data, and definitely in that case, like if we concentrate on this particular image, so different type of data that you need to feed. So one is the street data, where you only concentrate on the different street roads. Then you have building data, where are building located, so this is another layer. Then the vegetation layer, where are the green vegetations are available, and then finally when you integrate all the source, then you will get the realistic scenario. Now if we are interested now where from we can get all those kind of satellite image which we can further use and analyze. So there are different open source platform from where you can get those kind of satellite imagery. So for higher resolution, we also can get it from Bhuvan 2D or Bhuvan 3D, which is our Indian product, and the ISRO is taking care of it. We can also use the Google Earth Pro. We can also use, this is USGS, so also you can get good resolution, and also along with not only the satellite image, you can get some classified information as well. So there are certain land use information, certain sort of other metadata that also you are looking for can be downloaded. And there are other few open source as well, because I cannot name all of them here, but you can search on that. So some of the open source platform, they are also giving you the LULC, land use land cover map, okay, to certain resolution free of cost, so that you can use and analyze it. Now coming to the GIS analysis technique, what we normally do in this, what we can do with that GIS. So GIS stands for Geographic Information System. Now in this case, like you can use different platform, or you can also go for ArcMap. So ArcGIS is one platform. Then there are other software available. So QGIS is one of such open source platform where you can do some sort of spatial analysis as well. So if I talk about the analysis technique, so by this you can also do some measurement, you can perform proximity analysis, you can do some overlay analysis, terrain analysis, network analysis, and this list is very long, because depending on your purpose, like even you can do some watershed analysis, you can also do some sort of digital elevation modeling, and there are many such kind of tools that are available by which you can do some complex analysis spatially as well. So let us go one by one about this. Now measurement function in GIS, as because it is in vector, and when you fetch your information, or you just have certain sort of shape file which is some sort of extension for using the spatial map. So you need to first geolocate it properly. Okay, there are different world coordinate system. So with this WCS you just set it, and then you can work on it. So this measurement function makes spatial measurement easy to perform. Spatial measurement can be the distance between 2 points, or it may be just you can say also take a line, a polyline, so length of a line of a bound, or even the area of a polygon. So this is something that we can do very easily. Calculation can be simple in nature, measuring areas on one map, or more complex, measuring overlapping areas on 2 or more maps. So that is something some advancement in this particular platform, where you can also find out the overlapping area, intersection area, etc. Sometimes you require it for your analysis purpose. Coming to the proximity analysis, this is used to analyze the characteristics in a particular proximity from a certain feature. Say it is something like you have a national highway, say for example, and then you try to understand the settlement along the site. Now for that you can always do some sort of buffer analysis, that okay, it has some influence zone, immediate influence zone of say 500 meter, then the 1 kilometer, 1.5 kilometer. So you can observe that. So here in this case also, if you just try to understand it, so there is some sort of network, road network in that, and then the road sizes, like the width of the roads are also different. So that is why it is given in this particular legend. Now based on that, certain buffer is identified. So where you can see that the yellow color represent the nearest proximity, and then the towards the black is the farthest point. This can be done in many ways. So I give you another example. Suppose if you want to understand that the location, the facility location of a healthcare, okay, and how much population it is serving, how much area it is serving, because whenever we consider any facility, okay, where people will go, so there is some sort of threshold. So up to certain kilometer I am happy to go, beyond that it will lose that attractiveness. Suppose I give you example of shopping mall. If it is close, nearby, okay, and if it is away from my residential location, my home, after certain distance probably it will lose that particular attraction from my side. So this is something, you can say the proximity. In this case it forms buffers or zones and results in creation of surrounding coverage of any feature. It can be a building, it can be a river, it can be a road, it can be any point, it can be just a point of attraction, and from that point of attraction we can do this buffer analysis. It can assist to find out the village location nearer by road coverage of flooded area from a stream, or it can be a distance of the faulting landscape from a plain. So application, definitely it will differ person to person, but this is useful. Coming to the next one, the overlay analysis, technique for applying a common scale of value to diverse and dissimilar input to create an integrated analysis. So there are different layers. Say for example, if in this case it is just the marking of the customer base, then you have different street, then you have different parcel of land, then elevation, so which is giving you some sort of where there is some sort of low elevation or high elevation, and then also the land uses, different land uses and land cover, and finally the real world scenario. So obviously in this case the elevation of a low lying area or a river should be like lesser than whatever it's for the plain. So in such cases we can also identify, we can also do some sort of flood scenario analysis. So we can decide upon the flat plain, and accordingly we can make some restriction that okay, these are the restricted area where we should not make any such kind of settlement. This also helps to identify the best or most preferred location for a specific phenomena, because we have considered all of them. Say locating a shopping mall, definitely it should be somewhere where there is no water logging, so it should be away from those kind of water body or river. At the same time it should be located somewhere where there are certain demand or there are certain residential area. So that is something very important. This can be useful to solve problem like where to site a new housing development, okay, which sites are better for deer habitat. So it can be something like where you want to make certain kind of provision for settlement, or you want to reserve that as a forest or natural setup. So this can help in that overlay analysis. Coming to terrain analysis, which is very important to understand about the watershed, and also it will help to identify the different elevation. How this is going to help us, because based on this terrain we can make the drainage plan effectively, so that the catchment and then the disposal of the storm water can be very well planned. In terrain analysis, it actually analyzes and interpret the topographic features using the GIS. It includes the feature like slope, elevation and contour lines, generally used to understand how physical geography affects the decision making, and it can be applied to decide like route for military operation in a terrain for combat, natural disaster prone locations, which is nowadays very important because there are so much of problem happening in the Himalayan belt and all. So landslide or both natural and man-made disaster that are happening in those locations. So once we identify that, possibly we can identify those vulnerable locations, and accordingly we can have certain restriction or certain regulation on the functions in those areas. Next up is the network analysis, which is very common and people use it. This is used to analyze the complex network to optimize the movement with minimum cost. So this is something, again, this network can be a drainage network, it can be an electrical network, it can be the road network. So for that, making some sort of optimization of the route or shortest route, where like it can save the fuel, it can save the money and all. So this is something very useful depending on the location, depending on the distance and the functions that we give. So obviously for optimization we'll have some kind of objective function and then the constraint that we give, and then finally we can come up with certain analysis. So this can also help to decide about certain metro route, transit route, and then we can compare with different scenario. It consists of set of connected vertices and edges. Based on mathematical sub-disciplines of the graph theory, we can use it in case of road or rail network, drainage network of the city, as I already mentioned. You can see that some of the demonstration here. Now coming to the application of spatial method in planning, definitely it can be used for urban growth modeling. That what was 50 years ago and in last 50 years how the city has expanded, and also it can say that which direction, whether it is expanding radially or a particular location is actually getting populated, the other location is having the same profile that was there in 30 years or 50 years ago. So like that, the direction of the growth and also the overall growth we can measure. So here you can see that this is something that represent the city where in 1989 these red patches are nothing but the built up area. So in 2014 you can see that it has expanded almost in this particular part. Apart from something at the southwest, things are getting all these high built up, and then there are certain sort of drop. Obviously it is the transformation from non built up to built up. So there is a drop in the green vegetation, and now when we compare the same city in 2024, again it has expanded. So you can see how dense the red is now looking like. Some of the patches are left, and that is some of the parks or maybe some of the reserved area which are untouched, otherwise it is there. So irrespective of the city that I have represented here, you can try it out with your own city, and you can do some sort of temporal analysis that how things have changed over time. So application of spatial method can also be applied in transportation planning and network analysis to optimize the route, to plan the proposed route, how it can serve the accessibility and mobility part of that area, the connected area. It can also be used for environmental impact assessment. Now it's all about, you have a map and you just link it with, say, maybe if you want to make a real time map of the pollution, so that you can also do that, because what you need the point specific pollution data, and you fetch it in the GIS, and then you can actually predict the phenomena day and night time, how things are moving. In fact, if you recall this sort of map, okay, during the COVID time, okay, so different organization, they have come up with certain sort of spatial map showing the cases, the active cases of COVID-19 in different places. So we have world map, we have, say, country map, then we have certain city map. So that is also a application, may not be like which is very usual, but that was the case, that some sort of dashboard, some sort of spatial application that people have used, and to some extent it was also helpful in some cases. For environmental impact, yes, definitely, for different change in the ambient air quality that you can map, you can model. There are other few aspects like deterioration of the water level, or maybe some sort of other natural hazard that you can map. It is also useful for land use planning and zoning, so that you can make a control growth of that location. Now coming towards end of this discussion, that nowadays you must have heard about this spatial decision support system. So in this case, what is happening, that once we have that geo located information, and if it is fetched with the real time information, so some of the decisions can be very well made. So I give you one example of, say, transport network. If you have all this transport data available, and this is something you can say that the Google Map navigation, you must have used it in your journey somewhere, that where you give two locations and it will show you some of the alternative path, and also with the some information it will show the congestion and different colors, that red, orange or blue. Say for example, is a like very easy going road for blue, and then it is congested, then accordingly the time will change. At the same time, it will also show you the alternative time to time, that suppose if a road is congested, it will also give you the option to change the direction, or maybe you just alter the road, so that you can reach your destination as early as possible. So this is something help to take a decision that which path to be followed. Similarly, if for a administrator, if there are certain sort of network already being captured and monitored, so derouting some of the route, or maybe making certain sort of decision on certain signal system, that can be also possible with this type of application. So here it is just a dashboard that I randomly picked up from a paper, so where the routing optimization can be done with this information, where real time data are fetched into the system, and accordingly we can take a call on what to do with that. So for crowd management, for other drainage management, the application of this can be anywhere, even for some sort of resilient mapping, disaster mitigation, or maybe post disaster management. These are very useful tool. So for that, this spatial decision support system can be designed to help the decision maker with complex problem, because information are there, only the decision to be taken, and that can also be plugged with certain algorithm, so that decision can be taken accurately. It also provides essential information along with its location to assist the decision making, because that is very important. It also incorporate both GIS functionalities and analytical modeling capabilities to come up with that decision. So decision support system is another beautiful application of this spatial analysis. Now to summarize this, here we have understood that spatial analysis, how important it is for planning research. It has multiple advantages, and then it has application in multiple area, including the decision support system. Rather, apart from just some of the good map creation, accurate map creation, etc. Here also we have discussed about GIS analysis techniques. We talked about point, line, polygon. We talked about the attribute tables, etc. Also we have discussed about various application of spatial method in planning and the spatial decision support system. Now definitely some of you are working on this platform and you are doing some sort of spatial analysis already. So definitely for you, like, this is very easy to follow, but for those who are not doing it, or maybe you find it interesting and you want to know more, please go through those kind of basic information about that, the sources, the information I have mentioned about Bhuvan, Google Earth Pro, etc. Just browse through it, go through some of the papers, do some literature review, you will get certain insight, and then if you find that it is good to follow or good to use in your research, go ahead with that. So with that, I stop here for this particular lecture. These are few reading materials, and again, like the way I have explained some case studies to make you better understand about that approach or the method. In our next lecture, lecture number 54, we will be discussing about a case study, right? So till then, thank you for joining the course. We will be meeting you soon.